Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day everyone. Okay, now we are going to learn about fresh and hardened concrete. I am Associate Professor Teknologi Dr. Kedora Abdul Ghani from Civil Engineering Studies, University Teknologi Mara, Cawangan, Pulau Pinang. So, the learning outcome for this topic is to explain the basic science and engineering fundamentals pertaining to concrete ingredients, classifications, properties of fresh and hardened concrete, advantages and disadvantages of concrete as the construction material. Concrete is widely used as a construction material all around the world, okay, for a variety of purpose and type of building. Okay, so for the decorative purpose, okay, and also for the strength of the building. Okay, so the concrete, okay, when combined with reinforcement steel, okay, it will provide a stronger element, okay, to resist the load, right? So first of all, before we go to the procedures of concrete mix design, or the topic of fresh and hardened concrete, let us do some recap on the basic component of concrete. Concrete is made up of three basic components: water, aggregate, and Portland cement. Water, the function of water in concrete mix is to enable the chemical reaction so that the concrete becomes stiff, harden, and achieve the strength of concrete. Water is also used for lubricating purpose of the mixture of aggregate and the cement to facilitate the process of placing. Water used for concrete mixing must be clean, free from oil, free from any impurities, and fit for drinking purpose. This is to ensure the concrete mix gain the specific strength. Salt water cannot be used in the concrete mix because the sulfate would damage the reinforcement bar inside the concrete elements. Cement, usually in powdered form, acts as a binding agent when mixed with water and aggregates. Cement fills the void between fine and coarse aggregates particles to form a compact mass. There are many types of Portland cement to suit with the construction purpose. The commonly used is the ordinary Portland cement. Next is the aggregate. Aggregate is solid material which play no part in the chemical reaction that cause the concrete set. Aggregate function as mass particle to resist action from applied load, abrasion and percolation of moisture, and also the action of weather. Aggregate also function to reduce volume changes resulting from setting and hardening of concrete. Aggregate can be divided into two, which are coarse and fine aggregate. Coarse aggregate can be categorized as crushed or uncrushed stone, rock or gravel, having standard sizes between 10 to 40 millimeter of diameter. Meanwhile, fine aggregates are essentially any natural sand particles from the land through the mining process. Fine aggregates consist of natural sand or any crushed stone particles passing the 9.5 millimeter sieve, almost entirely passing the 4.75 millimeter sieve, and predominantly retained on the 75 micron meter sieve. For increased workability and for economy as reflected by use of less cement, the fine aggregate should have a rounded shape. The purpose of the fine aggregate is to fill the voids in the coarse aggregate and to act as a workability agent. The strength of the bond between aggregate and cement paste is depend on surface roughness and surface porosity of the aggregate. Aggregate with rough and porous texture increase the bonding between aggregate and cement, may increase in compressive and flexural strength compared to smooth surface aggregate. Aggregate will polish surface, aggregate with polished surface or with the smooth surface have less bonding with cement paste compared to those with rough surface. Aggregate with more angular surface would have large surface area and greater the bonding will be. And finally, the admixture. Admixture is counted as the additional material in concrete mix. The admixture are used in the concrete mix design when they have to solve certain concern pertaining the cost of construction, to achieve certain properties effectively, or to maintain the concrete quality throughout the process of mixing, transporting, placing, and compacting of concrete. So, we are going to learn about the fresh concrete. Before that, what's the difference between cement, concrete, and mortar? Cement is a fine powder that hardens when mixed with water and used in many building mix. Cement is a binder, similar to flour in a recipe. Flour in a recipe. The purpose of cement is to hold the other materials together, but you can't just use cement alone. You need the other material, and what you mix with the cement will determine the final product. These are ground into a powder and gypsum is added, creating the grey flour-like substance known as cement. When water is added to cement, it triggers a chemical process that allows it to harden. There are many different types of cement, but the type most commonly used in construction is Portland cement. Concrete. Yeah? Concrete is a composite aggregate, cement and water. The aggregate gives the concrete its mass, and the water activates the cement, holding it all together. What proportions of the mix will determine the strength, resistance to freeze and thaw, workability, and how long it takes to harden. Because it needs a low water to cement ratio, it is much thinner when mixed, making it difficult to use as a bonding element. Concrete is used in structural projects and is often reinforced with steel rebar to maintain its structural integrity as the soil beneath it settles. It is best used for support such as beams, walls, or other building foundation. And what about mortar? Mortar is used to hold building material such as brick or stone together. It composed of a thick mixture of water, sand, and cement. The water is used to hydrate the cement and hold the mix together. The water to cement ratio is higher in mortar than in concrete in order to form its bonding element. So when mixed, it is a much thicker substance than concrete, making it ideal as a glue for building materials like the brick. And for fresh concrete to be accepted, okay, it should be easily mixed and transported. Okay, number two, it should be uniform throughout a given batch and between batches of the concrete. It must be a consistency so that it can fill completely the form for which it was designed. Next, the fresh concrete must have the ability to be compacted without excessive loss of energy, and the fresh concrete not segregated during placing and consolidation, and must have good finishing characteristic. We move to the properties of fresh concrete. Okay, as I said before, the fresh concrete must have the consistency, uniformity, and workability. For the consistency, we use the Slum Test as rough measure of consistency of concrete, where it shows the wetness or dryness of the concrete mix, and change in slum will change the grading or proportion of aggregate or water content. For uniformity, it indicates that uniformity indicates that the concrete is mixed thoroughly until uniform appearance is obtained with all materials are uniformly distributed. Okay, so the concrete will be mixed for at least 1 minute. Okay, preferably 3 minutes in the mixer. Okay, and what is the objective of mixing? It is to coat the surface of all aggregate particles with cement paste and blend the ingredient into a uniform mass. Okay, so next is the workability. Workability is defined as the amount of mechanical energy or work required to fully compact concrete without segregation. This is important since the final strength is a function of compaction. And workability implies the ease with which concrete mix can be handled from mixer to its final compacted shape. And the common tests for workability are slum test, flow table test for flowing concrete, okay, BB test, and compacting factor test. The most commonly used uh, for measurement of workability is the slum test, because of the simplicity of the apparatus. Okay, and this test is most suitable for normal mix. Okay? However, it is not useful for stiff mix or for lean mix. Okay, let's look at the slum test procedure and the result. Okay, so figure 1 shows the procedure of slum test, where the steel slum cone is placed on a solid, okay, impermeable level base and fill up with the fresh concrete in 3 equal layers. Okay, so each layer is rodded 25 times to ensure the compaction. The third layer is finished off level with the top of the cone. The cone is carefully uh, lifted up. Okay, lifted up. All right, leaving a heap of concrete that settles or slumps slightly. The upturned slump cone is placed on the base to act as a reference, okay, and the difference in level between its top and the top of concrete, okay, the top of the cone and the top of concrete is measured and recorded to the nearest 10 millimeter to give the slump of the concrete. Okay, figure 2, okay, shows the result of the slump test. When the cone is removed, okay, the slump may take one of the 3 forms. Okay, the measurement is taken between the top of the cone and the top of the concrete after the cone has been removed. First form is the true slump. Okay, in a true slump, the concrete simply subsides, okay, keeping more or less to shape. Secondly, the shear slump. In a shear slump, the top portion of the concrete shears off and slips sideways. The shear slump indicates that the result is incomplete and concrete to be retested. Thirdly, collapse slump. In a collapse slump, the concrete collapses completely. This is an indication that the water to cement ratio is too high, okay, which is the concrete mix is too wet or it is a high workability mix for which a slum test is not appropriate. Okay, and the mix must be redesigned again. Okay, another slum is the zero slum or no slum at all. So zero slum is indicated of very low water to cement ratio, which result in dry mix. Okay, and this type of concrete is generally used for road construction, and it is not suitable for the structural or the building, the construction of building. Okay, and bear in mind that the true slump is the only slump that is valid and can be measured in the test. Number 2 is the compacting factor test. Compacting factor test is the workability test for concrete conducted in laboratory. The compaction factor is the ratio of weights of partially compacted to fully compacted concrete. It was developed by Road Research Laboratory in the United Kingdom and is used to determine the workability of concrete. Okay, and it gives the behavior of fresh concrete under the action external force. And the target value for the factor here is 0.82 until 0.92. The third test for workability is the VB test. Okay, the VB test allow for the evaluation of freshly mixed concrete, measuring its workability by determining the characteristic of mobility and compactability. The principle of the test is to change the shape of the concrete and measure the remolding in seconds. Okay, it is, however, the VB test is suitable for lean mix and stiff mix due to the size of the apparatus. What is the segregation of concrete? As I mentioned in the previous lecture, okay, the segregation of the concrete is the separation of constituents so that their distribution no longer uniform. It governed by total specific surface area of solid particle, including cement. It can be prevented by providing the direction of fall during dumping or dropping of the concrete in vertical. Okay, so reason of segregation of concrete. Okay, the concrete might be the mix might be very dry. Okay, so that the coarse aggregate tend to separate, right? Or the mix is very wet, where the cement grout tend to be separated from coarse aggregate, right? Or the specific gravity of coarse and fine aggregate differs, which increase the segregation, or the segregation might be uh, might happen due to over vibration of the concrete mix. Okay. Number two is the bleeding of concrete. Okay. So the bleeding of concrete is the water rise to surface of freshly placed concrete. Okay, it expressed as settlement per unit height of concrete and cause plastic shrinkage cracking. Okay, during compacting and until the cement paste harden, it is naturally tendency for the solid particle to move downward and displace water. And the bleeding of concrete can be reduced by using the finer cement, okay, using high alkali, addition of calcium chloride, okay, when we do concreting in the high temperature area, okay, or we use the admixture to reduce the water reducer, okay, or we use the air entraining agent. Okay, now what factors affecting the workability of fresh concrete? Okay, number one is the water to cement ratio. The ideal use water to cement ratio is 1 to 4. Higher water to cement ratio increase the workability but also increase void in concrete, which result in segregation and bleeding. Problem of shrinkage and creep of hardened concrete if using high water to content and lesser water to cement ratio will cause the lower the workability. Number two is the aggregate. Okay, workability reduced when using finer aggregate because of high specific surface area and also use of irregular and angular aggregate. Workability increase when using rounded aggregate, okay, because there is reduction in particle interference and the coarse aggregate in large size will reduce the total specific surface area. Okay, and higher the ratio of coarse aggregate and fine aggregate will lower the workability but risk to segregation, which need proper compaction or vibration. Number three is the admixture. Okay, so addition of air entraining admixture or plasticizer will increase the workability, right? And the fourth factor is the fineness of cement, where greater fineness increase the cohesiveness but reduce the workability. Okay, and for rapid hardening, Portland cement have very fine cement particle, which will reduce workability as compared to ordinary Portland cement. However, fineness of cement tend to cause concrete bleeding. And the last factor which affect the workability is the time and temperature, where high temperature will cause absorption and evaporation, hence it will reduce the workability. Now, let's look at the hardened concrete. Okay, so in the previous subchapter, we have learned about the fresh concrete, where the condition of concrete after the water touch with the cement. Okay, and due to chemical reaction, mixing water with cement will produce a plastic workable paste. But for hardened concrete is the phase that the concrete is in the hardening or gaining the strength uh, of the concrete. Okay, this is the flow of setting and hardening of concrete. Dormant period is the stage where concrete remain at plastic workable pace. The common initial setting time is about 45 minutes, depends on the type of cement used. The concrete is poured into molds and the shape still can be changed because the paste is still workable. Then, after 45 minutes, the paste enter the initial set stage. The paste begin to stiffen to such a degree that although still soft and become unworkable, and the shape cannot be changed at this stage. In 10 hours time, where it is called the final setting time. Final setting time, the paste is then enter the hardening phase where the paste become stiffened, okay, and can be regarded as a rigid solid. Okay, so hardening phase is where the concrete paste continue to harden and gain the strength, and it took about 28 days to achieve the designated grade of concrete. So what are the properties of hardened concrete? Okay, number one is strength, number two, durability, number three, permeability, number four, shrinkage, and number five, deformation under load and degradation under different environment. Let's go through one by one. Strength of concrete, defined as the maximum stress it can resist or the maximum load it can carry. The strength of concrete can be determined using flexural tensile tests, where the maximum load can be estimated with proper curing. Okay, so what is the curing? Concrete curing is the process of maintaining adequate moisture in concrete with a proper temperature range in order to aid cement hydration at early ages. Hydration is the chemical reaction between cement and water that result in the formation of various chemicals contributing to setting and hardening. The strength of concrete is measured using compressive strength test machine, either in the shape of cubes, cylinder, and prism. So what are factors influencing strength of concrete? There are the type of cement, age, and type of aggregate and admixture. Okay, where the type of cement, for example, rapid hardening Portland cement gains strength more quickly compared to other cement type. Yeah, right. Next is the degree of compaction. When the cement compact, it have low porosity and it will result in very high strength, where it can reduce the voids in concrete and trap air, capillary pores, gel pores, or entrain air. Okay. Next is the concrete mix proportion, where the cement content, aggregate cement ratio, amount of voids and water to cement ratio. Okay, so for aggregate to cement ratio, when the aggregate to cement ratio increase, compressive strength will be reduced. Okay, and for water to cement ratio, lower water to cement ratio will give greater compressive strength. Okay, and for admixture, adding the accelerator in the fresh concrete mix will speed up the initial set of the concrete. And the last factors influencing the strength of concrete is the type of curing and temperature of curing. Okay, there are two types of curing. It is the air curing, okay, udara, okay, or moist curing or water curing. Okay, so air curing and water curing would have influenced the strength of concrete. Okay, due to the hydration of the concrete. Okay, so concrete when it is cure using water curing, okay, it can maintain adequate moisture in concrete, okay, to aid the cement hydration at early age. Okay, so that the concrete will achieve the strength uh, better, okay, than the air curing. So these are the difference between air cured concrete, okay, compared to the moist cured concrete. Okay. Next is the durability of concrete. Durability is the ability to withstand the damaging effect of the environment over a long period of time and exposed to internal and external causes. Okay, the internal causes is the alkali aggregate reaction. Okay, for example, the volume changes of the concrete due to the differences in thermal properties of aggregate and cement paste and the permeability of the concrete. And for the external causes, is from the physical and chemical or mechanical factors such as the weathering, the extreme temperature, the abrasion, and electrolytic action. Next is the permeability of concrete. So what is the meaning of the permeability? Okay, concrete has a tendency to be porous due to the presence of voids formed during or after the placing of concrete. So to produce concrete with low permeability, full compaction and proper curing is essential, where low permeability is important in increasing the resistance to frost action and chemical attack in protecting embedded steel against the corrosion. So the higher the strength of cement paste, the lower will be the permeability. Next is the shrinkage of concrete. Shrinkage is a contraction deformation suffered by concrete even under no load. Yeah, it depends on the amount of drying that can take place, and the shrinkage is influenced by the humidity and temperature of the surrounding air, the rate of airflow over the surface, and the proportion of the surface area to volume of concrete. So the shrinkage can be categorized as plastic and drying shrinkage. Okay, so it is affected by the water to cement ratio, the cement content, type of, type of aggregate, yeah, size and shape of specimen, and the ambient humidity. So what is the plastic shrinkage and what is the drying shrinkage? Okay, plastic shrinkage is due to the hydration of cement, which result in volume reduction. It is aggravated due to loss of water by evaporation from the surface of concrete, particularly under hot climates and high winds, where the drying shrinkage takes place after the concrete has set and hardened. It is due to withdrawal of water from concrete stored in unsaturated air void. Lastly, the concrete in different environment. Okay, as you can see in the picture, the seawater might damage by the crystallization of salt. Okay, inside the mesh, reinforcement is much more open to damage due to the corrosion. And in acidic environment, where the pH is 6, okay, the concrete and the reinforcement must be protected by using suitable coating. And when the concrete under sustained or dynamic loading, it will increase the deformation and crack. Okay, so these are the uh, things that important uh, in fresh and hardened concrete. Okay, so now you have learned the characteristic of fresh and hardened concrete. Right. So I hope all of you enjoy this topic. Okay. And if you have any question, please directly comment. Drop your comment. Okay. And please like this video and share. Okay. Thank you, everyone. Assalamualaikum warahmatullahi wabarakatuh. Settle.